Alright, hey guys. I'm here. I'm going to go over a couple questions from 6.1, 6.4 review. And there was a few questions on there. So the questions I'm going to be going over today are going to be 6, 7, 9, and 12. So those are the four questions I'm going to go over. So I already have number 6 kind of drawn on the board. We have M, L, P. And on number 6, we're asked to do two different things. We're asked one, dilate from the origin by a scale factor of 1/2, and then also to rotate by counterclockwise by 90 degrees. Okay, so let's first go over the dilation. So if we're dilating by the origin, we want to know where is this point in comparison to the origin, and then we're going to cut the x movement and the y movement in half, since our scale factor is 1/2. So let me grab a different marker. So this is going to be 1/2 of triangle MLP. Okay. So if I'm at the origin right over here, to get to M, I have to go just up 4 units. Okay, so there is no horizontal movement, it's just a vertical movement. So we cut that vertical movement in half. So now instead of going up 4, we're only going to go up 2. And then that brings up M prime, I believe is what they asked us to label it. Same thing with L. L is at the coordinates of 6,4 or 6,2. And since my scale factor is 1/2, I cut both of those by 1/2. So now instead of 6,2, it's going to be at 3,1. And I can just divide them by 2 because my center is the origin. If it was anyplace else, I would have to augment that to adjust for it. And then P is at the coordinates 2, -4. So we cut that in half. And then we're going to be at 1, -2. So essentially this becomes my new dilated triangle. So M, L prime, P prime. Okay? So that's how we go about the dilation from the origin. I don't remember if I'm rotating the original or the new one, so let me just double check on that. So I'm going to rotate the original triangle 90 degrees counterclockwise about the origin. Okay, so if we're going counterclockwise, so this is clockwise, counterclockwise. And let's do counterclockwise in, what's another color that would come up? We'll just go with red. So when we rotate counterclockwise, we have to think about what happens to my x and my y values. Okay, so right now my M value is at the point 0, 4. L is 6, 2, and my P is at 2, -4. So the easiest way to do this is kind of take a point like this. And since it's already on the axis, it's a little easier. If we're going to rotate this 90 degrees, we just move it over to the other axis. And a rotation of 90 degrees puts this at the point -4, 0. So M double prime is -4, 0. just take a look at what happened to your coordinates. They switch places, and my x-coordinate is now negative. That's the pattern that's going to go on here with L. That's the pattern that's going to go on here with P as well. So I'm going to switch these around. So L double prime is going to be -2, 6. P double prime is going to be +4, 2. Okay? And -2, 6 should be roughly right about here. And +4, 2. +4, 2. So when you do everything on one, it starts to get a little messy. Let's go ahead and draw my triangle and connect all these red dots. So this is my new M double prime. This is L and P. And it makes sense since M and L were both pretty much in the same quadrant, so they should still be in the same quadrant now. P was in a different quadrant. It should be in a different quadrant than M and L prime, or double prime. Okay. So that's how you go over the dilations and the rotations. So look for a pattern when you're doing the rotations. Makes it a lot easier that way. So that way all you have to do is just manipulate the values. Okay. Let's take a look at number 7. Okay. So 7, we have a right triangle that's cut. Okay. And okay, my right triangle. Sorry, it's taking a little bit. Normally I would fast forward this, or at least that's what you should do. And we have 12, 16, 9, A, and C. So my best advice on a problem like this is to go ahead and separate the 3 triangles. Okay? And you want to draw them each in the same manner. So we have our big triangle. Okay? So we're going to do A, C, and then if I'm going to draw this as 1, we add the 2 together and we get 25. Okay? So over here is my other right triangle. And as you can see, this is the hypotenuse. A looks to be a little bit smaller than C, so it's going to be, well, A should be smaller than C. It's not in that diagram. Let's change that. There we go. So that way we're consistent. This is going to be 9. 9, 12, and the hypotenuse is A. Here is my middle triangle. We end up with 12 is the short side, 16 is the long leg, and C is the hypotenuse. So now that you have 3 different triangles drawn, you're looking to see which ones match up. So for example, if I wanted to solve for A, here we have the hypotenuse and the short side. And that matches up with the large triangle of the hypotenuse and short side. So we see that it's the variable is the same on both sides. So I'm going to go ahead and I'm going to set up a proportion. This and that. So 25 is to A as A is to 9. And we cross multiply. So these are a little trickier. So when I do proportion, I personally don't like to multiply the terms together. I prefer just to leave it like that, because generally something always happens where you're able to reduce them a little easier, and these are numbers that we can deal with a whole lot better than the other way around. So to get A alone, we're going to go ahead and we're going to take the square root of each side. And since I left it like this, A is going to be equal to the square root of 9 times the square root of 25. So A is equal to 15. And now we can go ahead and we can do the same thing over here for C, where now I'm going to use, and now that I have this side and it worked out nicely, where it's not a decimal or anything else like that, I can use these two sides over here in comparison. Okay, so let's go ahead and let's do that, and we should end up with the same thing. 15 is to 12 as 15 is to 12 as C is to 16. Okay, and again, I'm going to go ahead and I'm going to multiply these together. I'm going to leave it like that, because for me, it's always easier for me to do this, where 16 and 12 both have a 4 in common, and then the 3 and the 15 can be reduced down. So there we end up with C as being 20. Okay. And that's how you get A and C on this problem. Cool. Sorry, this was number 7, not number 6. But we're going to move on to number 9 and number 12. So number 9 and number 12 deal with arithmetic sequence and geometric sequence. So all right, so number 9, we've got an arithmetic sequence. It tells me that it's an arithmetic sequence. So we've got 1, 2, 3, 4, and then we've got 7, blank, blank, and 22. Okay, so if it's an arithmetic sequence, that means that there's a value that I am adding each time. So I need to figure out what that value is going to be. So you can kind of guess try a number, see if it works out, and then go from there. The other way to do it is, so essentially what's happening is that I am taking 7, I am adding a value x, getting a number, and then I am adding another value x, and it should give me 22. So that kind of sets up my equation. So my equation is now going to be 7 plus x is 22. And we can solve. We get 2x is equal to 15. So therefore x is 7.5. And then test it out. Does it work out? 7 plus 7.5 gives you 14.5. And then 14.5 plus 7.5 sorry, I messed up. That is not working. So, what am I doing wrong? Oh, I forgot. No, 7 plus x plus x. Yes. We're going to stop the recording right now. Now, I needed one more x. 7 plus x plus x. So, that's where my mistake was. So I'm going to redo this. Sorry for the error there, but sometimes happens, and we have to double check our thinking. So we get 7 plus x, that gives me this number under 2, plus x gives me the number under 3, plus x, and that should give me my 22 that I want. That makes more sense. So now we end up with 3x is equal to 15, x is equal to 5, and then that should work. 7 plus 5 is 12. 12 plus 5 is 17. 17 plus 5 gives me my 22. So, sorry, that was my error. Caught it a little bit too late before I explained everything, but hopefully you understand what my error was and how I corrected my error. And with that, we're essentially going to do the exact same thing for number 12, which is a geometric sequence this time. So on number 12, the values up here don't really matter too much. We have 7, 8, 9, and 10. We've got 24, blank, blank, and 3 over 8. So they tell me that this time it's a geometric sequence. So this time, instead of adding each time, I'm going to be multiplying. So it's going to be 7 or 24 times a number r, common ratio, gives me the number under 8. 8 times that r gives me the number under 9. 9 times the r gives me 3 over 8. So this time my equation or my setup is going to be similar, but instead of addition it's going to be multiplication. So it's going to be 24 times r times r times r is equal to 3 over 8. So that gives me 24 r cubed is equal to 3 over 8. To get the r cubed alone, eliminate the 24. We're going to divide each side. And all that does is that brings the 24 underneath in the radical, or in the denominator, sorry, on the opposite side. And we can simplify. That turns into a 1. That turns into an 8. The 3 and the 24 will reduce down. So now I have r cubed is equal to 1 over 64. And we can take the cube root of each side. We end up with r is equal to cube root of 1 is 1. Cube root of 64 is 4. So r is equal to 1/4. All right, let's test our theory. 24 times 1/4, we're essentially dividing by 4. We end up with 6. 6 over 4. Okay, 6 times 1/4. You end up with 6 over 4, or 3 over 2. And then do it again. 3 over 2 times 1/4, 3 over 8. So it works out. Okay? All right, so that's kind of a little bit of the review. These take us all the way back to Module 1, where we talked about arithmetic and geometric sequences. Sorry for the little hiccup here on number 9. Hopefully still made sense. If you have other questions, let me know. Good luck.